Disclaimer: the following video involves using paid software DMDE. There are different licenses for it. If you use it for personal use to recover your own files, you can get away with the Express license or the standard license, probably the Express. However, if you use it to recover client data commercially, then you need to purchase the Pro license. Please refer to the end user license agreement for DMDE for further information. DMDE is very affordable, so please buy the appropriate license. I would like to add that for the purpose of using it with HDDSuperClone, you should activate DMDE in Linux on the computer that you're planning on using it with. And if you're planning on using a live CD with no persistence, then I would suggest choosing the manual activation the first time and then saving that license file so that you can keep reloading it every time you boot the live CD. So for this demonstration, I'm going to show how to use DMDE to extract data through the virtual disk driver of HDDSuperClone. So first thing I've got to do, choose a new project. We're using direct HCI mode for this drive because it's really screwed up, got a weak head. We know it has lots of errors. I'm going to choose the source drive. And that's why we're trying to do data extraction on it, because this drive would take forever to clone, so it's better to try and target the files if we can. I'm going to use an image file for the destination. You could use another drive if you wanted to. I'm going to start the virtual disk driver since it didn't start automatically when I went to HCI mode. So now, connect. Go to virtual mode 1, and I'm going to uncheck the slow driver now because I can. We do not want this on. It's checked by default just so bad things don't happen, like if you're trying to do a part robe or something, but for extracting data we want to uncheck this. So now we're going to start DMDE. Oh, we forgot to do something, but we'll just park this over here. We forgot to click start. If you don't click start, you don't see the drive. So now, once our runtime is going, and this is operational, and you can't just go by this, because if you're looking at this thinking it was going, it wasn't, because we hadn't hit start. So runtime's going. So now I'm going to get that same menu back up, go to drive, select this task. Now you can see we have device SDV. That is the default name for the virtual disk that HDDSuperClone creates. So we're going to leave this, leave the show partition. We're going to click OK. And now it's searching for partitions. You can see it's reading here. Now, here's our first pop-up. And you're going to get this if you got a drive with errors. As a matter of fact, what I should have done before at the other screen is click on parameters. So I'm going to do that now to show you that is it really a good idea to do this, otherwise you're going to keep getting pop-ups. IO errors, we're going to say always ignore IO errors because it's got errors and we don't want to bother with it. The other thing I want to uncheck or change is fill errors. I want to fill it with zeros, so that way it's not filling it with some pattern, because it might help in recovery of damaged pictures to not have not have something other than zeros in it. And additionally, I'm going to go to additional, and our IO buffer size in sectors is 256. Our cluster size by default in HDDSuperClone, unless you changed it, is 128. So we're going to match that. If you change the cluster size in HDDSuperClone, you should probably match that here, whatever you change it to. So I'm going to click OK. Go with ignore all for ignoring the errors. Alright, so now we can see it's found our partitions on this drive. Our main partition, 150 gigabytes, it's called Acer. I guess it came out of an Acer laptop. So we're going to select that, and then we're going to open volume. So now you can see we've got a list of the main root of the file system. So to extract data, we need to know where it's at. I'm going for some user pictures. I happen to know where they're at, and I'm targeting a very small number of pictures for this demonstration because the entire picture folder on this drive is 15.5 gig. So targeting this specific folder here, so I put a checkbox by it. And you can check multiple folders if you want. Unfortunately, at this point in time, you can't see how big it is, but you can. So when you go here, which is recover data, click on that. Now we get a chance to see the size, and it says 220 megabytes. Okay. So I want to change where I'm recovering this to. So now I know where the files are going to be recovered to. Here, if you didn't change them before, you can go to options. This is another place where I/O parameters are, where we're filling with zeros, always ignore errors. We're matching our cluster size with our I/O buffer. Here's one other thing you're going to want to do now, and you can get to it later, but in the event handler, you're going to want to open that up, and fail to open file, you're going to want to say skip. I don't know, but I'm assuming that happens because there's errors in the MFT on this, when it can't complete opening, it can't find the file to open it. By open, I'm assuming it means to read it. And an error reading file means that means it finds a bad sector, has an error in it. This is where we're going to change that to move to bad. That way it'll move it to it'll move all the bad files that have errors to a separate folder. So now we're going to click OK to that. We're going to go back to the source and destination so that we can click OK here. Click OK. It's asking to make sure that we know that our destination is not on the source, and we're going to say, yep, we're good. So now it started the recovery process. Now, I'm leaving this in virtual mode 1 because this is the fewest amount of steps it will take to recover the data. It's going to take a while, but every read goes through the entire process of starting with phase 4, then trimming or dividing, in this case trimming because I didn't change it to dividing, and scraping. And it does that for each read along the way instead of coming back and doing it after the whole, like when you're cloning. So that way, every read is as good as it's going to get. I didn't change any timers to make this any faster, which I could have, but I'm leaving it default. This will be the best possible file recovery for this drive in the least amount of steps. We're going to let it go and come back to it when it's done. Oh, I do want to show there's an action button here. Click on that and wait, because it has to wait for it to finish whatever process it's doing. Right now HDDSuperClone is trimming a sector, so DMDE is waiting for it to respond. It's trimming a really big spot. I picked a bad time to do this. Okay, so you see now it comes up. You can choose to abort recovery right now if you wanted to stop it. The action button is like instead of just being like a stop or cancel button, it gives you choices. And here's where, if you wanted to, you can go back into device I/O parameters, make changes, click OK. You can come back to here. You can get into the event handler and make changes here if you want to. Like say you forgot to say skip, and hopefully you didn't say move to bad because you wanted to do that right from the very beginning. So we're going to cancel out of that. And as contrary as what you would think. Once you've made changes here, you want to resume the recovery, you would just click cancel here and it comes back and we're back running again. One thing about DMDE is it doesn't give you an overall picture of the recovery. It only shows you the percentage of the current file. So really the only way we kind of have to tell where we might be at is by looking at the finished or the domain size, which we see is 0.22 gigabytes. So I remember this was 220 megabytes of recovery, so I should be getting close. There was a little bit of initial recovery, or from reading some things in the file table. So it's probably going to be a little bit more than 220 by the time it gets done, but I'm guessing it should be getting kind of close, and that's pretty much the only way you can tell. Okay, so it has finished, as you can see right around the 0.24 gigabyte or 240 megabyte mark. It says failed to open directory to files 0 of 2. Basically there's 2 files that it could not open, or for some reason probably due to MFT damage. It says bad files recovered 93, so it says there's 93 damaged files. So click OK to that. Now if we go to our recovered folder, we can see this. This is the folder that I recovered, and there's images here. So recovery was successful. This is the bad folder. So these were where all the files went that were bad, and it keeps the folder structure, which is kind of nice. But you can see that there's these are the files that had errors in them. This one opened, but if you see that line right there is probably a bad sector. What is this? This is a bitmap, which I found bitmap files usually will open up. The other ones you can see don't show in the preview. Maybe you could get them, fix them, or repair them. But anyway, you can see we have successfully recovered the files. We know which ones are bad because they're moved into this bad folder, and that is the extent of this video.